Cloud cover. A cloud cover is a visible mass of tiny droplets of water and ice suspended in the atmosphere. The clouds form as a result of condensation. Condensation is the process by which water vapor changes into liquid and as a result of cooling below the dew point. Dew point refers to the temperature at which the atmosphere, being cold, becomes saturated with water vapor. Types of clouds. There are different types of clouds which are classified on the basis of altitude, appearance, structure, and formation. High-level clouds: cirrus, cirrostratus, and cirrocumulus. Middle-level clouds: altostratus, altocumulus, and stratocumulus. Lower-level clouds: cumulonimbus, cumulus, and nimbostratus. Stratus clouds are important in weather since they influence rain formation. Measurement of clouds. The cloud cover is measured by observation of the sky at specific times and recorded in octaves. That is 1/8 of the sky. Observation of the sky gives an estimation of the sky covered. The more accurate way of measuring cloud cover is by use of weather satellites that orbit the Earth, relaying the information to the ground satellites through remote sensing. Lines drawn on maps connecting places with equal cloud cover are known as isonefs. Humidity. Humidity is the amount of water vapor in the atmosphere. This vapor comes from the ground surface, water bodies, and from plants. The amount of water vapor in the air is influenced by temperature, size of the water bodies in a given place, and the prevailing winds. High temperatures influence evaporation. Thus, areas with high temperatures and presence of large water body have high humidity. Winds influence the buildup of vapor. When winds are calm and blowing from a water body towards the land, the humidity is high. Strong winds blow away the vapor, hence low humidity. When air is holding the maximum amount of vapor it can hold at a given temperature, it is said to be saturated. This is also known as dew point. Types of humidity. There are 3 types of humidity, namely absolute, specific, and relative humidity. Absolute humidity. Absolute humidity is the actual amount of water vapor in a given volume of air at a given temperature. It is expressed in grams per cubic meter. Specific humidity. This is the weight of water vapor in a given mass of air expressed in grams of vapor per kilogram of air. Relative humidity. This is ratio between the actual amount of water vapor in the air to the maximum of water that the same air can hold at the same temperature. Measurement of humidity. Humidity is measured using an instrument known as a hygrometer. A simple hygrometer consists of 2 ordinary thermometers, a dry and a wet bulb thermometer. A wet bulb thermometer. It is described as wet because its bulb is wrapped in a muslin cloth and dipped in a small dish of water. When air is dry, water evaporates from the wet muslin cloth, cooling the bulb and lowering temperature as opposed to dry bulb thermometer. The readings are taken from the dry thermometer. The next reading is taken from the wet bulb thermometer. The difference in the readings is transferred to a humid table which gives the relative humidity as a percentage. If the difference in temperature is large, the relative humidity is low. The main factors that influence humidity are air temperature, air pressure, supply of moisture, and latitude. Wind. Wind is air in motion. Its characteristics are expressed in terms of speed and direction. The direction is always given as that from which it is blowing and expressed from the points of the compass or in degrees from the true mouth. Movement of air is caused by differences in pressure, that is, air moves from areas of high pressure to those of low pressure. It is an important weather element because it is a medium of transfer of heat, moisture, and movement of clouds. Factors influencing wind direction and speed. The wind blows in different directions and varying speed. This is caused by pressure gradient. Pressure gradient is the difference in pressure over sea or land. The wind tends to blow from regions of high pressure to regions of low pressure. Steep gradient wind moves faster. Coriolis force. The direction to which the wind blows is also influenced by the Coriolis force. This is the force resulting from the rotation of the Earth that tends to deflect object or air to the right in the northern hemisphere and to the left of the southern hemisphere. This implies that as winds blow from the southern hemisphere, they are deflected to the right, while winds blowing from the northern hemisphere to the south are deflected to the left. Centrifugal force. This is the tendency for air to move clockwise in the northern hemisphere and anticlockwise in the southern hemisphere. Presence of relief barriers. The rough nature of the Earth's surface creates friction to wind due to the presence of features that obstruct the wind, thus changing wind direction. Planetary winds. These are the world's most prevailing winds or blow frequently. They are found in the northern and southern hemisphere. There are many types of planetary winds. One example is the monsoon winds. The monsoon winds. These are seasonal winds that change the direction as the seasons change. Experienced in Southeast Asia, Japan, India, and Northern Australia. Other examples of planetary winds are trade winds, westerlies, and polar winds. Local winds. These are winds affecting a relatively small area and for a short period of time. They are influenced by the presence of a relief feature such as a mountain or a larger water body such as lakes and seas. The example of local winds are the breezes, mountain, and desert winds. Land breezes. A breeze is a gentle wind that affects places near water bodies. They occur during the night when the land, being cooler, develops high pressure and the sea that is relatively warmer has lower pressure. Consequently, a cool wind blows from land seawards. The sea breeze. The sea breeze occurs during the day. At this time, the land gets heated quickly and low pressure develops. The sea remains cool, resulting in high pressure. The winds then blow from the sea towards the land, a sea breeze. This helps lower the daytime temperatures. Breezes, mountain and valley winds. In mountain areas, the local winds that blow up or down the mountain are anabatic winds. These are local winds which blow from valley bottoms up the valleys to the hills' tops. They are cool during the day. Measurement of wind. Wind direction. The wind direction is determined using a wind vane. The arrow points in the direction from which the wind blows, which is the point of origin and the name of the wind direction. The wind vane should be placed on a tall building at least 10 meters from the ground. Obstacles, like tall structures and trees, should be avoided because they cause friction, reducing speed and changing direction to the wind. A windsock. A windsock could be used to give general direction for the wind. The mouth of the sock faces the direction of origin for the wind. A windsock is mostly found in airstrips. Wind speed. The velocity of the wind is measured using an anemometer. An anemometer consists of metal caps at the end of the arm or rods that rotate freely when wind blows. The faster the wind, the more the rotation, which are transmitted and recorded on a meter in units known as knots or kilometers per hour.
How much water we use in a blanket? Well, that is the ever. So, it's a calculation.
Atmospheric pressure. Atmospheric pressure is the weight of the air exerted at any point on the Earth's surface. Air pressure at the sea level is higher than over the highlands. Factors influencing atmospheric pressure. The following are factors that influence atmospheric pressure: altitude, temperature, and rotation of the Earth. Altitude. Pressure decreases as altitude increases. This is because rising air expands, spreads over a larger area, giving less pressure. Temperature. When temperature rises, the air becomes warm and light and the pressure drops. Conversely, when temperature drops, the air is heavier, which causes the pressure to rise. The Earth's surface, therefore, is divided into low-pressure cells and high-pressure cells according to seasons. The pressure cells, in turn, leads to the development of wind systems over the Earth, since air moves from high-pressure to low-pressure areas. Rotation of the Earth. The Earth makes a rotation in 24 hours, and yet the circumference reduces towards the poles. Air tends to be pushed towards the equator, where there is more space, spreads, and exert low pressure at the equator throughout the year. Pressure distribution over the Earth can be summarized as subtropical high pressure zone, the temperate low pressure, and polar high pressure. The equatorial low pressure zone experiences high winds called doldrums. The main features of this zone are high temperature throughout the year, high humidity, low pressure, convergence zone of trade winds, hence the Intertropical Convergence Zone, ITCZ. The ITCZ moves north and south of the equator following the apparent movement of the sun within the tropics. 23.5 degrees north, 23.5 degrees south. Due to convergence, low pressure and high temperature, convectional rain accompanied by thunderstorms are common weather elements within the equatorial belts. Subtropical high pressure zone. Subtropical high pressure zone is found around 30 degrees north and 30 degrees south. Sources of trade winds and westerlies. Air moves out of this zone to low pressure areas in the northern and southern hemisphere. The temperate low pressure or subpolar low pressure zone. It is found around latitude 60 degrees north and 60 degrees south. Winds which blow into these areas are westerlies and polar easterlies. Polar high pressure. The poles, 90 degrees north and 90 degrees south, experience polar high pressure. Pressure belts shift but are discontinuous on the Earth's surface due to physical variations. Pressure cells move or shift with air masses. Air masses. An air mass is large volume of air with uniform characteristics in temperature and humidity depending on the point of origin of the air mass. There are four main types of air masses. These are equatorial air masses, tropical air masses, polar air masses, and Arctic and Antarctic air masses. A boundary separating masses of different characteristics is known as a front. When the different air masses meet, warm air tends to rise as cold air undercuts it, then descends forming a depression. Measurement of atmospheric pressure. Simple mercury barometer. Air has weight. It therefore exerts pressure on the Earth's surface. The atmospheric pressure is measured using a simple mercury barometer or an aneroid barometer. A simple mercury barometer consists of a glass tube, 1 meter long, and a ball containing mercury. The aneroid barometer. This is a more refined automatic instrument. An aneroid barometer Precipitation is the deposition of falling out of water vapor, moisture, or frozen water from the atmosphere towards the Earth's surface. The fallout may reach the surface or remain suspended in the atmosphere. The different forms of precipitation include rain, frost, rime, snow, sleet, hail, dew, mist, and fog. Types of fog exist depending on formation, thus radiation fog, advection fog, hill fog, frontal fog, ice fog, Arctic smoke, and urban fog. Measurement of fog or mist is based on visibility. Rain. This is the most common form of precipitation. It mainly consists of droplets of water varying in size. It's formed as a result of condensation of risen moisture to form clouds. As the amount of condensed water increases, the clouds become denser and darker. Eventually, the cloud becomes too heavy to be suspended in the atmosphere and falls as rain. Types of rainfall. Rainfall may form due to the presence of or influence of the following: physical barriers, high temperature, and meeting of different air masses. The types of rainfall are relief rain, convectional rain, and frontal rain. Relief rain. Relief rain occurs in areas where onshore winds rise over hilly or mountainous regions lying parallel to the coast. It also occurs in areas where moist air forced to ascend relief features far from water bodies. The rain-bearing winds lose their moisture on the windward slopes winds. Convectional rain. Convectional rain is commonly experienced in tropical areas or mid-latitudes during the summer season. Areas around the equator get intense heating from the sun. This results into warm air rising in form of convectional currents. When this air reached higher in the atmosphere, the moisture in it condenses to form cloud which later fall as rain. Convectional rain falls mainly in the afternoon and is accompanied by thunderstorm. Frontal rain. This type of rain is common in temperate areas. When warm, moist tropical winds meet cold, dry polar winds, frontal rain may result. When the warm air mass meets with the cold air mass, it is forced to rise up. This is because of the undercutting by the cold air and the warm air is lifted up. It gradually cools, condenses, and falls as rainfall. Frontal rainfall is usually very heavy and is accompanied by thunder and lightning. Measurement of rain. The basic instrument used in measuring the amount of rainfall is a rain gauge. A standard rain gauge consists of a metal cylinder. Inside the cylinder is a jar in which rainwater collects. A funnel is used to direct the water into a jar. In measuring rainfall, the rain gauge should be in an open place away from buildings and tall trees. The space should be firmly fixed on the ground. Rainwater that is collected is measured in 24 hours using a special measuring cylinder marked in millimeters. The water collected in the jar is measured the following day about 8 a.m. before evaporation takes place. A measure of 20 millimeters means that on a flat ground, water will accumulate to a depth of 20 millimeters without sinking or evaporating. Rainfall record. Rainfall records include monthly rainfall total and annual rainfall total. Mean monthly rainfall. In calculating the mean monthly rainfall, get the figure by getting the sum of the monthly rainfall totals for a particular month observed over several years, for example, 10, and dividing the sum by the number of years of observation as follows. Get the records for October for 10 years and divide by 10, 200, 220, 180, 200, 170, 180, 200, 150, 250, and 200. Mean monthly rainfall for October is 195 millimeters. Mean annual rainfall. Rainfall intensity is equal to total rainfall over total number of hours it occurred. The atmosphere. The atmosphere is the thick layer of gases surrounding the Earth. This layer of gases is held on the Earth by gravitational pull. Composition. The atmosphere is composed of a variety of gases, smoke, particles, and water vapor. Nitrogen 78%, oxygen 21%, inert gases 1%, which include argon, hydrogen, krypton, neon, helium, and ozone, carbon dioxide, and water vapor. Particulates include solid matter in suspension, for example, dust, pollen grains, mild pores, smoke, and salt particles.